So hopefully you can see my PowerPoint here. We are going to be talking mostly today about core logic for the knowledge processing engine and methods, and some interesting relationships that are in the Auros IQ product for bringing about this autonomous knowledge evaluation. Feel free to start to comment at any time and ask questions. I'll do my best to field those things as we go. Okay. So as I mentioned in the first presentation, hopefully you caught it, one of the trends that has been emerging over the last couple of years, especially last year, is the utilization of the knowledge-aware approach for capturing knowledge in a model format, this knowledge packet, granular, modular, actionable unit of knowledge, and bringing it to bear in a digital environment or in some automated way, and having outcomes that are tracked and fed back into a process, right? So this is what we mean by autonomous knowledge, evaluation of knowledge. So to do this, we need to start to understand the core logic of how the process works and what are the elements of the process of doing that. So with respect to the Auros IQ product, this is the product map that we generally show to show kind of the feature sets and the modules around Auros IQ. But let's focus here on the three primary technology components of Auros IQ. And you can see they are one and the same with the concepts behind knowledge aware. It's not a coincidence. We intend and build Auros IQ to bring about the knowledge aware vision. So there is the idea of an assessment control that tracks and causes the provisioning of knowledge, the knowledge packet, the granular actionable unit of knowledge that can encapsulate knowledge as a model, and knowledge processing engine that can understand the knowledge models. So when we talk about the knowledge packet, this granular, modular, actionable unit of knowledge, sure, you can just put in text and we can bring that text and the image and files to someone who needs to make a decision and they can read it, okay? And we can track what happens, how long they took to maybe create a state of passing or failing or whatever state there might be associated with that knowledge packet. But the future isn't in this passive consumption of knowledge. The future is more in the automation of that process. And to get there is not a lot of effort from the document. In fact, I would argue that it's less effort with much more value. So what am I talking about? With the knowledge packet, at least in the Auros IQ version of it, there are table-based models, and they're in the format that we call basic knowledge packets. And these tables, and I'm going to kind of go through one example here in just a little bit, we call them value tables. And the value tables can express rules and relationships, model knowledge for attribute kinds of things. If the material is X and the gross weight is Y, then we should have architecture Z. These kinds of rules or models or knowledge models. Very basic, simple, but very powerful. And of course, the parametric kinds that drive or check CAD models or CAA experiments and things like that. With these table models that you can author in a basic knowledge packet in Auros IQ, you can encapsulate or model a wide variety of knowledge. And each model can work in conjunction with other models through parameter relationships to produce more complexity, bottom-up complexity. So the point here is, as we try to drive towards how do we automate this core logic and how does it work, we first need to understand that there's the knowledge packet is how we capture knowledge. They don't have to contain models, but if as appropriate, they should. And the table model and a basic KPAC is one kind. The second kind, and there's just two, pretty straightforward, simple, is a process model. So a process model you can think of as like a Visio diagram looking thing, right? but it's actually a model of the process that can be exposed to core logic. So we call them in Auros a method knowledge packet. So it's a different, what we call core template, and it contains this process kind of model. And in the process models, you can have decision models, like how do you decide what material, how do you decide architecture, these are decision models, or process flow, series of events of standard work with timing and all kinds of stuff like that. And again, I'm going to show you examples. Okay, so the core logic of the process is based on the models, and we're going to get into it, of these two types. So let's look at this basic type first. Now, some of you probably already familiar with them, but I'm going to go ahead and start with not a super complex one, but not a super simple knowledge packet with a model. So what you see on the screen right now is a single knowledge packet. It has, text, and it's got some, text here. But importantly, it has the model. In this model, there are 3 parameters. Hopefully you can see that. Housing material, bore depth, and a counter bore depth. And the object of this model is to say what the counter bore depth should be. And obviously, if it's not at that depth, there's something wrong. Okay, so visually, this model is actually quite easy to see, right? I mean, you can kind of see that if the material is steel and the bore depth is 4, then the counter bore depth should be 1.7. So as an expert having to create knowledge, I could have written it up in text, put in attached an Excel file, or write a bunch of statements that kind of say this. But this KPAC core logic gives us the ability to encapsulate the knowledge in a uniform format across authors, but also express it in a deterministic way that we can then test, right? So what I mean is that after I authored this, the model can be exposed to the knowledge processing engine and we can test it. So as I said, if we pick the material and we have a counter bore depth, we can evaluate on the fly what that means. So we know from that table that was now executed or evaluated that the counter bore depth should be 2.51 when the material's aluminum, right? So if we change the counter bore depth to 2.51, just testing our model here, we can evaluate, and now we have a complete logical response that is now passing, has a status against this knowledge model. Now you can see there's a relationship between the knowledge packet and the idea of counter bore depth and 3 parameters. And we're going to come back to this idea of parameters. One of the parameters, counter bore depth, we are evaluating to pass, and 2 of them are required to make that decision. We call this input parameters, and the rule output is an output state. So this knowledge packet with these 2 inputs produce an output state of pass when the counter bore depth is evaluated to 2.51. Okay, so if you're familiar with CAD or any modeling systems, you're going to start to see how this plays very nicely, and you can start to imagine how we can connect this to model spaces. So this is just a really basic example of a table-driven knowledge model that now, when the knowledge is provisioned to a modeling space, we might be able to use the parameters in a way and inform that model. And that's really what we're going to be showing tomorrow. Okay, so that was a basic value table and demo. Now I kind of want to show you some variations of the method model. So this is an example of a method knowledge packet. So again, I could have described it in text. Here's the details of the knowledge packet, and here's the method model. And the method model is exactly probably what you're thinking. It is a process model that we can evaluate. Behind the scenes, it's still just parameters and values, just like the last one, but the parameters and values now are coming from the method. So we have something called a basic, and I'm going to show you editing one of these in just a second so you can kind of see how easy these are to create. And a basic step has, the most basic set of features. It's either complete or incomplete. So if we complete it, the knowledge processing happens, the parameter is set to complete, and we can move on to a different kind of step in this process model. This is called the decision or branch logic step, and it has a model in and of itself that's asking a question, and based on the answer of the question, it is routing us further down the process model to the next step. This is another very basic step. And if we complete that step or attest to its completion, we can move down to another step, right? And this is a step of type assessment. And if you're familiar with Auros, you're in an advanced session, hopefully you are. The idea that you can attach an assessment to a step is a very powerful concept, because now you can cause knowledge from a variety of sources to be provisioned into a step and never have to manage the maintenance of the step. And the standard work that's here can be driven from that set. Okay, that's one example. Let me show you another example. And in this example, it's very much like the other step, but this time I've got two different kinds of elements here that we did not have in the last one. So these have timing elements. So in this case, we can have a timing element that says that it's a simple due date kind of element, and we can set a target for the due date to be, let's say it was last week, and let's say we started it today. Well, now we are schedule missed because we did not complete it, but it knows that we didn't complete on time, but it is complete, and it moves us on to the next step. So this is a basic step. We've talked about those before. And the next step is a new type of step called the logical step. The logical step is just very much like branching, but instead of branching, we are going to evaluate to some qualitative state. So if we want to see what that looks like, I'm just going to open this up and say, so this one has got one parameter. It's in this Latin text here. And we can see that when this parameter is in different ranges, it means something different qualitatively. So for example, if I were to report that this parameter in my project is 7, or some digital tool provided that value, we have an output state of red, right? And that's going to drive output states and accumulate output states and roll it up and eventually create an output state for the entire method, okay, which is up here. I will just change that. I don't like to have red. I think that is green. And we're green, and we can move on. So this was two different kinds of steps. What I'm going to do now is really quickly go into an editing environment just so you can get an idea how easy it is to create these models. So I'm going to go into edit. And I'm going to open up my editor, and I'm just going to do something really simple here. I'm going to break this link, move this out, and I'm going to simply add another step. So the steps are all typed, and they do different functions. In those examples, I showed you a branching logic step, I showed you a logical step, I showed you a basic, I showed you an assessment, I showed you a checkpoint. I'm just going to go ahead and throw in another basic step here. Okay, and I'm going to just do some housekeeping. Take these and distribute them evenly. I'm going to make sure they're aligned through the middle. And now I'm just going to make the connections again. And we're connected. It's that easy. Here's the new step that we created. As we go through the process, our new step is here, and it is completely interacting with the model. So I wanted to take that opportunity to show you how easy it is to create these models. There's a high return on the investment of creating the model in the knowledge packet. So now that we've got models, I want to talk about something that's really, really important. This is where we get into the advanced part of the session. As I mentioned, the essential technologies to make the autonomousness work is the assessment control, the knowledge processing engine, and the knowledge packet. The knowledge packet contains the model. The assessment control is handling which knowledge packets and persisting the values and the state and the statuses and applying to specific program, project, or context. And the processing engine is that sits between and understands how to process the individual models. So if we think about this, there's an important set of relationships that come about that make customizing processes really, really good. So you've got the knowledge packet, which again contains the knowledge model, the value table, or the method. You have the knowledge processing engine that understands the model, and given any sets of inputs to those parameters, can produce an output state. And in the Auros IQ core logic, I think there are 15 specific output states that can be achieved. And you have the assessment control. So for the advanced people here, what I want to convey to you here is that the knowledge model and the output states are connected. The knowledge processing engine understands the models that can be conveyed to it through the knowledge packet. And it produces output states, one of these 15 states. And those states are then mapped to the conformance states. And hopefully you know what I'm talking about because we're in an advanced session. And what's really interesting about this is that the knowledge processing engine, the abstraction between the models always producing a consistent set of output states, and then Auros IQ allows you to map those consistent universal output states to a conformance state, which is of your business process's choosing. Pass, fail, conforms, non-conforms, red, green, yellow, complete, incomplete, whatever terms you want to use. And at a big company, you would use different terms in different work practices. So the power here is that the knowledge models are consistent and abstracted across everything, all workflows, all models, all everything. The knowledge processing engine understands that it can produce these output states that are consistent across universally, but you can then map them to conformance states to report against a specific project in language that's specific to your project. Okay, so this is an important concept. I think most of you probably have had some level of experience, but understanding that there's abstraction exists and is powerful, that the output states are universal regardless of the model types and models, and that it's all based on the parameters and the output states that are produced. And then we can roll up and bring together those output states to create a conformance state, which says, well, your architecture is the right choice or wrong choice, or you're conforming to this standard, or you're non-conforming, or you're complete with the evaluation standard, or you're not. right? And so that language is of your choosing, of your work group's choosing. Okay, I think I'm a little bit over, but I'd be happy to take questions.
Cool. I think we might have some questions. Indeed, we do. John is asking, are these KPACs that need to be created?
They need to be created. They replace the documentation, standards, requirements, lessons learned, best practices, rules, heuristics that you normally accumulate in. So the knowledge packet is a far more efficient and effective way to capture and life cycle that knowledge. Auros IQ as a tool set has lots of tools to do this, to bring about efficiency in this capture, refinement, life cycling concept of knowledge. So there are ways to automate the transference of units of knowledge from document spaces to the knowledge packet model. But over time, it generally is proven to be quite feasible and efficient to do just by replacing the old processes. In fact, it's more efficient. So yes, they do have to be created.
Okay, so hopefully, yeah, I think you covered John's questions. Hopefully, if not, let us know in the chat. So yes, Andre is asking, for the knowledge model to work, do we need a toolkit to link Auros to the CAD model, or is it already available in the basic license?
It's a really good question. It's all available. So the knowledge processing engine is built into Auros, and that's why you can create a knowledge packet, put a model in, and then just test it, because the knowledge processing engine is there. You can also, we do have the knowledge processing engine as a key abstraction that you can actually place inside of some modeling environment just to reduce chattiness, or you can leave it server side. I know I might be getting a little technical here, but the core product comes with the knowledge processing engine. You don't need a CAD connection to do it. You can connect any external system to the knowledge processing engine on Auros side and avail yourself of all of those capabilities. When you have a CAD connector like the ones we sell, like say to Creo, the connector is really just getting context and parameters and measures and values out of CAD and getting the right knowledge packets and talking to the knowledge processing engine back on the Auros side. But that's all, yeah. So you don't need a CAD connector to do it.
Okay, I think we have time for one more question from Nicole. Can you change the type of a KPAC yet from standard to method, or do you need to start the KPAC that way?
You know, there is no point and click way to do it. If you need to do a bunch of them, let me know. We can. It's easy enough. We know how to do it, but we have not implemented the. At least to my knowledge, we've talked about it. So maybe it's gotten into the product, but to my knowledge, I'm sorry, there's so many changes now I can't keep track of them. To my knowledge, there is not a point and click way to do it, but we can do it for you if you want to.
Got a couple more questions. I mean, technically, we could take them and then just, the next session starts at 2:15. So Susan, any thoughts on having a selected assessment control bulk builder from the home COP to be attached to an assessment method step, if not possible yet?
It's a fantastic idea. I understand why you want to do it, and I would think we will eventually get to it, but no. So thoughts on it? It's a great idea. It's something that it's a logical next step in the advancement of doing more complex sets of work instructions that involve multiple assessments and getting multiple assessments on one step done. She's talking about how do we automate that process in another dimension of complexity, getting many created at once on a step. I think that's what you're talking about, and I fully agree. That's a really good thing to do. Obviously, your use cases are extremely advanced and requires that.
Cool. And then just finally, can we assume that KPACs are built based on machine learning algorithm?
They're not. We can't assume that. So the knowledge packet models are a formalism. We've developed a way to encapsulate a wide variety of constraints, heuristics, go through all those things in these two formats, the method format and this table format. They're created mostly, through point and click ways. We do have AI-based ways to create the knowledge packet and understand when a knowledge packet needs to be created. But to create the model itself, it's a formalism. And that formalism, that abstraction, and then is understood by our knowledge processing engine. And that's a lot of power there, because it means anybody of any author in any domain, in any language, can create a knowledge packet, and the knowledge processing engine still knows how to evaluate it, right? Knows how to produce data about it. It passed, it failed. It was one of these 15 output states. It took this long to process. This is who did it. All that data gets collected. So by having these formalisms for expressing knowledge, you gain a lot of value.